All right, thank you guys. I'm very grateful that I'm here. It's been a long trip. I just landed and came running from the airport to here, so I'm very glad I made it on time. So with Repsol, we're creating something very novel. It's a new carbon capture technology, but it's set up in a different way. So it's a carbon sink battery. Essentially, it's a battery that captures CO2 as a byproduct. So today, carbon capture is viewed as a cost problem. You got to bring down the cost down as much as possible. But the problem with it, it's more than just a cost problem. It's a business case problem, because the business case of carbon capture mostly depends on carbon credits, which is relying on policy and people's goodwill. But if you strip that away, then you have no business case that it can stand on. And that's why we gave it a business case, and it's a battery that people already buy. So you buy a battery, and you get carbon capture as a margin on top. So how it works is we have two steps. The first step is the air contactor, which brings down the cost of carbon capture substantially. And then the second step is the regeneration. So traditionally, regeneration costs energy. You have to drain energy to regenerate CO2. In this battery, regeneration happens as a byproduct of the battery's cycling. So regeneration is a byproduct. So you cycle a battery, and the regeneration happens as a byproduct. So how it runs is you run it continuously for the air contactor, but then you regenerate the CO2. You run the battery when it's most effective. When the prices are cheap, you regenerate the CO2. When the prices are expensive, you sell electricity back to the grid, and you regenerate CO2 as a byproduct. So it's a battery that captures CO2. You get two revenue streams from every cycle. So this allows customers to advance their energy goals while eliminating 100% of their emissions. So you don't have to sacrifice your energy goals right now to achieve net neutrality. With this battery, you firm up power, you complement the grid instead of adding an additional strain, and you lower energy costs, and you eliminate emissions. So while it's a more expensive battery, today it has a similar payback period as traditional batteries, and higher lifetime value because of the additional revenue stream. And it has a similar payback period because currently it's heavily subsidized by policy. So you get carbon capture's revenue that subsidizes the cost of the battery. So in the future, when you drop the cost of the battery, like solar panels, like they started off expensive, and you drop the cost, they become sustainable on their own. That's the vision we have for the battery. It's expensive today, subsidized by policy, that becomes affordable and stands on its own as a battery. So today we're validating it with Repsol. Here's the live pilot dashboard. You guys can scan the QR code and view the system's operating parameters. The biggest number we're proud of is that we're validating with Repsol 600 kilowatt hours per ton for direct air capture energy consumption. And the system is going to be validated over 1,000 hours and for a 2-ton per year capacity. We started this validation last week, and it's currently underway. Thank you. Then I'll leave it for Repsol to give their comment.
Thank you very much, Adam. I'm here again. So why is this interesting for Repsol? So just a couple of words about the context. In Europe, the regulation is promoting the uptake of renewable fuels, including renewable fuels from non-biological origins, and this includes e-fuels. And the e-fuels, when they are produced from renewable hydrogen and eligible CO2 sources. These eligible CO2 sources can be biogenic CO2 and CO2 from DAC, from the direct air capture. And there are 3 different types of DAC solutions, from with liquid solvents, solid solvents, and electrochemical systems. Spiralwave has an electrochemical approach that is really promising in terms of energy consumption. But the problem is the situation is that the TRL is low. So we need the POC to confirm performance, to confirm stability, to confirm its potential scalability. So what we expect from this POC is exactly that: generate robust data to assess the viability of Spiralwave technology as a potential DAC solution in order to support e-fuels strategy in Repsol. Thank you very much.
And sorry, one last sentence. If you believe that CO2 should be a byproduct of a battery, or just be a byproduct in general, just like as it was a byproduct of an emission, let's talk after this. Thank you.